Happy day students, this is Dr. V. Sindhu, Assistant Professor from the Department of Computer Science and Information Technology. It is happy to share with you the third class on R data structures, that is the vector. Already we had two sessions, one about R Studio and another one on the basic operations of R programming. The data structures in R are used to store the information related to analytics. Vector is a one-dimensional in storage, whereas list is the one-dimensional heterogeneous storage, and matrix is a two-dimensional storage, and an array is a multidimensional storage. A data frame is a multidimensional storage with heterogeneous data, and a factor is a categorical data storage unit. Now let us move on with the basic data structure, that is the vector. A vector is a one-dimensional storage that is used to store homogeneous information. Homogeneous means the data that belongs to same type. Here is an example. We have an image where it contains a set of pens, but in between we can see one pencil, which means it is not of same type. It has two items, one is a pen and another one is a pencil. So it is not a vector. So when it comes to this image, you can see only the set of pens, which means it is homogeneous, all are pens. The same way, the vector is used to store information that belongs to same data type, which means it can be either an integer data or it can be a string data. Every data that is stored in the vector should be of the same type. Why vector? Vector is a foundation data structure in R. It is useful for data transformation. It is used to make operations faster, and the vector is created on its own in R programming when we create a sequence of information. The syntax for creating a vector is shown in the screen. It is vector name implies or equal to C of element 1, element 2 followed by element n, where C should be in the lower case, which means that it is concatenating all the elements to create a new vector. And also here we have few examples. The first one is a numeric vector which contains all the numeric values, and the second one is a vector of string which contains the name of the fruits, and the third one is a logical vector which contains only the two values, either true or false. So this way we can create different types of vectors. That means what are all the data types that can be stored in a vector. First comes the numeric vector, second one which is a double value, which means that it can accommodate both the whole values and the decimal values, and followed by the integers, which is only the whole numbers, and followed by the character vector where it is interpreted as an integer or as a character. Also we have a date vector followed by a complex number vector and a raw vector, which is used to hold the hexadecimal values of the data that is given as raw. Here are some of the operations that we can perform on a vector. The first one is how to find out the data type of the information stored in the vector. Using a type of method, we can find out what is the type of the data that is stored in the vector. Also, we can make use of operations on the vector, like how to find out the average, the sum of values stored in the vector. Also, we can perform logical operations on the elements that are stored in the vector. Here we summarize certain operations that we can perform on the vector. One is arithmetic and statistic operations. Also we can perform string and character operations, logical and conditional operations, also indexing and subsetting, and combining and repeating. These are the operations that we can perform on the vector. Moving on to the arithmetic operations, we do perform all the basic arithmetic operations on the vector. Here we have two vectors x and y, and we do perform the addition, subtraction, multiplication, division, the modulo operation that gives the remainder. Also we learnt all these in the previous video, how all these operations functions in R programming. Next comes the statistical operations. The basic statistical operations can be performed on the vector data. Here we have a vector which contains a set of information. We can perform the summation of the elements inside the vector. We can find out the mean of the data inside, median, also which is the minimum value, what is the maximum value, and what is the standard deviation between these values, as well as the variance, to list a few, and many more statistical operations can be performed on the vector data. Now comes the string operations. R has a large package of string operations, and let us see how the string operations are performed on the vector. And we have used a few here to list out the usage of vectors in string operations. So, we have a vector called names, which contains 3 names. So, we can simply print the names. We can apply the string function toUpper to convert them into a capitalized data, and we can also change it to lowercase by making use of toLower function, and we can make use of nchar, which will give you the number of characters in every string, as well as we can make use of the paste element, which will add multiple values to every element in the vector. Here we have made use of doctor dot, which means that for every element inside the vector, the suffix doctor will be added. Also, we can make use of collapse operation, which converts the vector into a single string, making use of the connector. The next set of operations we will learn is the relational and the logical operations. The relational operations include all the comparison operators like greater than, less than, equal to, not equal to, and the logical operation is used to combine the relational operations. In this example, we have two arrays A and B. A is compared for greater than 15 and B is compared for the values less than 5. So, when the value in vector A is greater than 15, it returns a true, else a false. The same way, if the values in vector B is less than 5, it returns a true, else it returns a false. And now we combine these two using an AND operation, and as we all know, the AND will give a true only when both the inputs are true. So, if we check into this, only for the third data, both the outputs are true. So, there we have a true and all others are false. And as we know, the OR operation is false only when both the outputs are false. So, in this, the data is false only for the second data where both the outputs are given as false. So, the next set of operations that we can perform on a vector is indexing and subsetting. Indexing is used to point out an element inside, one or more elements inside the vector, and the same is also used for subsetting. So, you can pick out a handful of data from the vector and you can create a new set. That is what we call it as a subsetting. Here we can make use of single indexing, multiple indexing, ranging, and exclude indexing, as well as logical indexing and using which operations. So, single indexing is picking out one element from the array. So, x of 3, in the element x, the third element is picked out and it is 30. And multiple indexing is C of 1, 4, it picks out the first element and the fourth element. The range element 2:5, it picks out the elements between the second element to the fifth element. And exclude indexing, we do make use of minus before the index, which means that that particular element alone will not get displayed. Here it is given as x of -1. So, we do get the output as all the other elements other than the first element. Also, we have logical indexing. It will pick out the elements that satisfies the conditions. Here the condition given is x greater than 25, which means that only the elements that satisfy the condition that is greater than 25 alone will be displayed as an output. And here 30, 40 and 50 are the elements, and using whiches will give out the position of where a particular element lies. Here we have given which x double equals 40, 40 is in the fourth position. So, our result is 4. So, this way we can index the elements inside the vector and we can also subset them and create a new set of vectors. Another salient feature of vector is recycling. Here we have two vectors, one is A that has 5 elements and another vector is B that has 2 elements. And now I do a comparison operation between this A and B. So, the first element of A is taken and the first element from B is taken and it performs a comparison operation checking A is greater than B and returns a true. The second element in A is 20, the second element in B is 40, and check whether 20 is greater than 40 and it returns the condition false. And now I take the third element 30 from the first vector and there is no element in the second vector. Here vector go for the recycling. As shown in the figure, the same elements 2 and 40 are repeated so many times required as in the vector 1. So, 30 is now compared with 2 and says that 30 is greater than 2 and the result is true. The same way this continues until it completes all the elements from the first vector. Also, we perform an addition operation between these two vectors A and B. The first element in A is added to first element of B. Second element of A is added to second element of B, and now when comes the third element, there is no element in B. So, it recycles the first value again to add it with the third value. This is how the vector will manage to transform the data. Now, let us move on to few more operations that can be performed on a vector. So, on a vector we can perform the basic set operations like finding out the union of two vectors, intersection of two vectors, difference between the vectors, and also we can check for whether two vectors are equal or not. And also we can make use of the membership vector which says true or false when an element is found in the vector or not in the vector, it shows you a false. Also we can check for the match operation where you compare one element is there inside the vector, it shows you in which position that element is there. If the element is not inside the vector, it returns a NA, which means that not applicable. And we also have the concat operation where we can combine two vectors. Here we have a vector A which is a numeric vector and a vector B which is a string vector, and concatenating A and B, we do get a new vector, but the data is transferred into a string type that contains both the numeric value and the string value are converted into a string. So far we learned the operations that can be performed on a vector, and now we will move on to the purpose and need for vector to be used in the R programming or analytics. First thing is, it is an efficient storage method. It is easier to perform statistical analysis on vectors. It is easier to perform data cleaning and data transformation. Visualization is also possible with vectors. Now, let us move on with the simple analysis process with the vectors. Here goes an example where we can perform a simple analysis we can do with the vectors, and it is a BMI calculation with the formula BMI is equal to weight in kilograms divided by height in meters. We have two inputs here, both are vectors. One is the weight vector which is described in kilograms, and another one is the height vector which is given in centimeters. Since the formula is in meters, the first thing is we need to do a transformation, convert this height in centimeters to a meter. Here comes the formula. The centimeter in height is divided by 100 to convert it into meters. Then we do perform the BMI calculation using the formula and store it in a new vector called as BMI. So now BMI is a vector on which we are performing an statistical analysis. To perform the statistics analysis together, we can make use of the function summary of, which returns the highest value, the lowest value, the mean, the median, the first quadrant and the last quadrant, and also we can display the standard deviation and the variance between the set of information. Now, the BMI vector is taken to categorize using an if-else statement to categorize the BMI values as underweight, normal, overweight and obese, and the results are stored in a vector called BMI category. The set of vectors can be tabulated using a data frame to show the information in a tabulated manner. Also, we can create a graph using this BMI category vector to display how many people are underweight and in other categories also. So, this way we can make use of vectors to analyze simple information, and here goes an exercise for you where you have the vector of the calorie intake for 7 days and you will perform the following task: finding out the total and average weekly calories intake, identifying the days where the intake is above the average, using a bar plot to visualize the calories intake per day. Use the max and min function to find out the highest and the lowest calorie days. Thank you. See you in the next class. Thanks for watching. Like, share, subscribe and comment to the MOP classroom. Thank you.